Okay guys, so video 4 here. We're going to talk about graphs of logarithmic functions, but the first thing we need to remember is those transformations. So just like all of our others, we know that y is equal to a, and we're going to write the word log here though, and then we're going to have bx minus h plus k. Just like every function we've done so far, a, b, h, and k all do the same exact thing. Remember, A is your vertical stretch or compression. B is your horizontal stretch or compression, does opposite of what we think. H is your horizontal shift left or right, opposite of what you think. And then K is your vertical shift up and down. It goes the direction it's supposed to. So we're still using them to help us with our tables. Alright, so example 7 tells us that it wants us to use transformations. It says start with the graph of f of x equals log base 3 of x, which is the one we did in the previous video, and use transformations to sketch a graph of each function. So, example 7. So remember that log base 3 of x, we created a parent table for it. We said we were going to use 3 to the y equals x because we changed it to exponential form. We picked some x values. And so we chose -2, -1, 0, 1, and 2. We plugged them in. We had 1/9, 1/3, 1, 3, and 9. And we'd said we had a vertical asymptote at x equals 0. And we had graphed it and looked at it. So now let's look at A. A wants us to graph f of x, which remember same thing as y, equals log base 3 of x, and then a plus 2. Well, that plus 2 right there, remember, it's our k value. It's not in the parentheses with the x, but it is being added or subtracted. So this is going to be our vertical shift, and it's a plus 2, so we expect to see it go up 2. Alright, so when I go to do my table for this, it's my k that's going to affect my y values. So we're going to take our y's and we're just going to add 2 to them. So our x's, we're not doing anything. There's nothing inside there with that x. It's just x. So it's going to stay the same. So we had 1/9, 1/3, 1, 3, and 9. And for our x's, and then our y's, we're going to add 2. So we're going to take that -2 plus 2, -1 plus 2, and all I'm doing is right here, so in case you need to see it written. And so we get, was that 1, 2, 3, and 4. And then my vertical asymptote is x equals 0. Well, again, nothing changed, nothing affected my x's, so my vertical asymptote's not going to be affected either. And then all we have to do is plot these points. So I'm going to draw in my vertical asymptote. And plot my points. So 1/9 and 0, 1/3 and 1, 1 and 2, 3, 3, and 9, 4. I'm going to connect the dots here, put arrows on both ends, make sure I don't touch or cross that vertical asymptote, and there's the graph for A. Okay, so moving on, B wants us to graph f of x equals log base 3 of x minus 1. The minus 1 now is in parentheses with the x, so it's going to be horizontal. It's being added or subtracted, so it's going to be a shift. And it says minus 1, so we know because it does the opposite, we're going to go to the right one. So when I go to make my table here, we have that x minus 1, so that means we're going to take our x's and we're going to add 1 to them. But there's nothing there to affect my y's, and so I'm going to leave y as it is. So I'm going to take all my x's and add 1. So 1 and 1/9, 1 and 1/3, 2, 4, and 10. My y's are going to stay the same, so -2, -1, 0, 1, and 2. And then I have that vertical asymptote. Well, it was at x equals 0, but remember, we just added 1 to all of our x's, so now it's really at x equals 1. So when we go to graph this, I'm going to move that over a little bit more here. I'm going to graph my vertical asymptote, which is over at 1 now. And I'm going to plot my points. Just recounting, making sure I counted those correctly. Alright, I'm going to connect the dots and put arrows on both ends, making sure I don't go across that vertical asymptote. Now, something I did forget to do on A was I was also asking for you to state the domain and the range and the vertical asymptote. So we already set our vertical asymptote. So on B, let's go ahead and state our domain and our range. Our domain was, for the parent function, remember, 0 to infinity, but we went to the right one. So we can look at the graph and we can see what it is, or we can do like we did in that previous example where we set what we're taking the log of, so in this case x minus 1 greater than 0, and solve. So you'd add that 1, and so you know x has to be greater than 1, which means it's going to start at 1 and go to infinity. And then, of course, our range, this is a log function, so our range is going to be from -infinity to infinity. Okay, on C, it wants us to graph f of x equals negative log base 3 of x. That negative there, we know that that's going to be a reflection across the x-axis. Alright, so when we go to do our table, I don't have anything with the x to affect it, but I do have that negative sign in front. So remember, that's like -1 times log base 3 of x. So we're going to multiply our y's by -1. So our x's aren't changing. And our y's are being multiplied by -1. And then we're going to graph that. Sorry, it's not very straight. Yeah. All right. Excuse me. So I'm going to graph my, oops, I forgot to write it though. Where is my vertical asymptote? Well, did anything affect my x's? No, so it's still going to be there at 0. So I'm going to graph it. And then I'm going to plot my points. And we're going to connect the dot. Again, connect our points, draw our arrows, don't cross that vertical asymptote. And so remember, a reflection across the x-axis just means our graph's going to flip upside down. And then just check, does it look like it did it? Yeah. All right, so your domain, well, we can look at the graph, or we can look up at the top, and all we had was an x. So if I take what we're taking the log of, set it greater than or equal to 0, it's just x is greater than 0. which means it's 0 to infinity. Remember, our x didn't have any transformation, so it didn't change it, and our range for logarithms is always negative infinity to infinity. Okay, and the final one on example 7 wants us to graph f of x equals log base 3 of negative x. Remember this negative here, and negative is a reflection, and my x's are changing, which means it's across the y-axis. All right, so when I go to do my table, this time we have the negative inside with x, which we know just means that x is going to change signs, but if it had been a number, we would do the opposite, so it'd mean we'd divide by negative 1. And there's nothing outside of the x, so my y's are going to stay the same. So all my x's are divided by negative 1. My y's stay the same. My vertical asymptote was x equals 0, but remember it's divided by negative 1 as well, but it makes it just still stay in the same place. It's not going to affect it. All right, so let's graph this. Drawing your vertical asymptote. And let's plot our points. So negative 1/9, negative 2, negative 1/3, negative 1, negative 1, 0, negative 3, 1, and negative 9, 2. So as you can see, our graph did reflect across the y-axis. Uh-oh, missed that point. So let's draw our graph, connect your points, draw arrows, put arrows on both ends, make sure you don't cross that vertical asymptote. Alright, so we already said our vertical asymptote was at x equals 0. What is our domain? Well, looking at the graph, you can see it goes up 2, but it doesn't include the 0. Or looking at our equation, remember it was a negative x, that's what we took the log of. So we know the negative x has to be greater than 0, but when we divide by negative 1, remember your sign is going to flip. So that means that x has to be less than 0. So that's going to be from negative infinity up to, but not including the 0. And then, of course, our range, it's a logarithm. So hopefully we got that down now that it's negative infinity to infinity. All right, so this is where I'm going to stop this video, and we will start on the next one.